Minimum must-run MMR or must-run generation MRG is a crucial concept in power system operation that ensures the stability and reliability of the system. Must-run is exactly what its name depicts. Power plants will always supply electricity to the grid in all conditions, many utilities around the world using it as per their system design and need. MMR could be utilized smartly due to many reasons but not limited to 1. Like dividing electric network into grouping to avoid high short circuit level. 2. System design constraint. 3. A redial network islanding. 4. Renewable generation maximum utilization. 5. Saving any specific portion of a system during blackout by creating an islanding. 6. Transmission constraint and many other reliability stability factors. One of the problems with electricity is that it should be consumed when generated. So, power plants has to run according to the demand. There are a mix of power sources: coal, gas, nuclear, wind, solar, etc. from which you get power. But power plants are not like gas stove where you can just plug in and start cooking. There are technical limitations like nuclear power. If started, needs to be running for longer period, 18 to 24 months on baseload. Similarly, coal-powered power plant needs to maintain some level of minimum running in the blast furnace. Hydro and gas-powered plant can be turned on and off as required, and finally renewable energy is intermittent. It will depend on weather condition. MMR is a constraint that requires certain generating units to always be online and producing a minimum amount of power. These units could be typically older, less efficient, or more expensive to operate, but they are necessary to maintain system stability and reliability in some cases. The MMR requirement is usually specified by the operational planning after system studies and is based on factors such as the system load, the availability of other generating units, and the need to maintain adequate spinning reserve. In case of any unforeseen islanding, MMR left with certain area generation can easily help back to restore a power system. Minimum must-run MMR generation is also important in islanding situations. Islanding occurs when a section of the power grid becomes disconnected from the rest of the grid, and power must be supplied locally. In these situations, it is important for power plants to have enough MMR capacity to meet the local demand for electricity. This is particularly important in remote areas or on islands where there may be limited backup power sources. By having enough MMR capacity, power plants can ensure that they can continue to supply power to the local community during an islanding event. Energy Control Center considering generally this filter criteria typically known as merit order. 1. Must run. 2. Minimum technical limit. 3. Variable cost. 4. Transmission constraints if any. Take an example of urban areas where there is either insufficient transmission capacity or generators are needed for voltage control to maintain reliable operation. For local reliability, must-run units are running even at break the merit order, and in some cases it is resulting renewable curtailment. Renewable and must-run. As told earlier that in the power sector, a must-run status refers to a designation given to certain power generating facilities that are considered essential to maintaining the reliability and stability of the electrical grid. These facilities may include hydroelectric dams, natural gas peaker plants, or other types of power plants that are considered critical to maintaining a consistent supply of electricity to consumers. As a result, these facilities are given priority access to the electrical grid, and are typically not subject to the same market forces as other types of power generation. When load dispatch centers receive injection requests into the grid by various generators with quoted price, they arrange those requests in ascending order of their prices. Preference to supply power is given to least price power plant, then second least, and so on. This process continues till demand required is matched with supply from generators. This mechanism is known as merit order dispatch. It is for safeguarding the interest of consumer. Renewables have different case due to enormous benefits and social advantages associated with them. Government was handholding renewables, so it promulgated renewables as must-run power plants no matter they make up in merit order dispatch or not. Power generated from renewables will never be curtailed, unlike gas and thermal power plants. It will encourage developers to invest in renewables. The MMR requirement is important for several reasons. First, it ensures that there is always enough generation capacity available to meet the system load, even during periods of high demand or unexpected outages. Second, it helps to maintain the stability of the power system by ensuring that there is always enough spinning reserve available to respond to sudden changes in load or generation. Finally, it helps to reduce the risk of blackouts or other system failures by ensuring that critical generating units are always available and operational. In many utilities, all type of generators which are based on renewable energy sources are given must-run status. This is because of the fact that running cost of such generation is almost zero. Solar wind power, such generators have to be kept running, and if any requirement of backing down of generation arises, coal gas-based generation should be backed down. All renewable energy power plants except biomass power plants, cogeneration plants, and municipal solid waste MSW plants with capacity of 10 megawatts and above shall be treated as must-run power plants and shall not be subjected to merit order dispatch principles. Let us see the example around the world. There are many examples of how minimum must-run MMR generation helps in islanding situations around the world. One example is the island of Hawaii, which has a high percentage of renewable energy sources such as solar and wind. In the event of an islanding event, the MMR capacity of the power plants on the island ensures that there is enough backup power to meet the demand for electricity. Another example is the island of Puerto Rico, which experienced a widespread power outage in 2017 due to Hurricane Maria. The MMR capacity of the power plants on the island played a critical role in restoring power to the island, as it ensured that there was enough backup power to meet the demand for electricity while the main power grid was being repaired. In addition, many remote communities around the world rely on MMR generation to ensure a reliable supply of electricity. For example, in Alaska, many remote communities rely on diesel generators for power, and the MMR capacity of these generators ensures that there is enough backup power to meet the demand for electricity during an islanding event or other emergency situation. Minimum must-run MMR is a critical concept in power system operation that ensures the stability and reliability of the system. By requiring certain generating units to always be online and producing a minimum amount of power, the MMR constraint helps to maintain the balance between generation and load, ensure adequate spinning reserve, and reduce the risk of system failures. These subject lines are written as in general information error and omission possible. The rules have introduced the concept of intermediary procurers to ensure that must-run power plants keep operating. Intermediary procurers shall operate as traders of electricity on the power exchange. The intermediary procurer shall be an agency or entity nominated by the central government or a state government, and shall purchase power through a competitive bidding process. The rules are not clear whether the sale to intermediary procurers can be made simultaneously with the ongoing PPA arrangements of the generator, or if it is to be made only upon the curtailment of power by the scheduled procurer and in respect to the amount of power curtailed by the procurer. While the renewable energy sector was granted must-run status under the IEGC, the introduction of the rules will push the envelope for renewable power generation. In addition to regulating the renewable energy sector, this development will give necessary security not only to investors and generators, but also to project lenders. Must-run is exactly what its name depicts. Power plants will always supply electricity to the grid in all conditions. When load dispatch centers receive injection requests into the grid by various generators with quoted price, they arrange those requests in ascending order of their prices. Preference to supply power is given to least price power plant, then second least, and so on. This process continues till demand required is matched with supply from generators. This mechanism is known as merit order dispatch. It is for safeguarding the interest of consumer. Renewables have different case due to enormous benefits and social advantages associated with them. Government was handholding renewables, so it promulgated renewables as must-run power plants no matter they make up in merit order dispatch or not. Power generated from renewables will never be curtailed, unlike gas and thermal power plants. It will encourage developers to invest in renewables. In the power sector, the term must-run refers to power plants or generating units that are required to operate continuously or at all times to meet certain operational requirements or system needs. These plants are typically dispatched by grid operators regardless of the prevailing market conditions or the cost of generation. Must-run status is often assigned to power plants that provide essential services such as grid stability, voltage support, frequency regulation, or other critical system requirements. These plants are considered vital for maintaining the reliability and security of the electrical grid. Assigning must-run status to a power plant ensures that it remains operational even when it may not be the most cost-effective option for meeting electricity demand. Grid operators prioritize the dispatch of must-run units to ensure the stability and reliability of the power system, especially during periods of high demand or system stress. In some cases, renewable energy sources like hydroelectric plants or nuclear power plants may be designated as must-run due to their ability to provide consistent and reliable power output. These plants play a crucial role in ensuring grid stability and meeting the energy needs of consumers. Overall, must-run status is an important concept in power system operations, ensuring that essential power plants are available to support the reliable operation of the electrical grid. India example. Must-run status means any power generated by the power plant should always be accepted by the grid. Indian Electricity Grid Code 2010 notified by the Central Electricity Regulatory Commission (CERC) accorded must-run status to renewable energy projects solar, wind and small hydro to promote use of energy from renewable sources. While all other conventional generating stations can reasonably predict the energy availability from the generating station and therefore can give proper declaration of availability to enable the load dispatch centers to schedule. However, the wind power and solar power cannot predict advanced declaration of availability. This aspect has been recognized by the Commission (CERC) while granting the special status of must-run power plants to solar and wind generators. Under this status quo, the regional and state load dispatch centers should allow injection of power from wind and solar power projects, and they should not restrict the same on the grounds of variation in the grid frequency or the schedule. However, the grant of exemption to wind and solar projects should not affect the grid stability.